that you've started. So it's basically a continuation of everything that you've studied in AS. So we have to start from the beginning. TK, I'll just give, I mean, most of the things that we study will be focused on A2, but we would have to always cover some of the previous stuff as well, just for revision's sake. Now, for organic, we can what we can do is we can start with naming quickly. Just a second. So for organic, we can start quickly with naming. Just a quick recap. That's one of the very basic things because you still have to, in A2 organic chemistry, you still have to name compounds properly. So just a very quick, because you've already done this. So I'm just going to go over this very, very quickly, naming and structures. Now, when it comes to structures, you already know that there are 3-4 different types of formulas. The very first, very basic thing that you should know about is which atom makes how many bonds. Carbon usually makes 4 bonds, although it is capable of making just 3 bonds as well, like in graphite. The other element that is usually found in organic compounds is hydrogen, that makes only 1 bond. Then you've got nitrogen, which makes it's group 5, so it makes normally it makes 3 bonds. And you've got oxygen, and that makes 2 bonds. It's in group 6. It needs 2 electrons, so it makes 2 bonds. You've got many different types of formulas. The first one is a molecular formula. A molecular formula just tells you the total number of atoms in a molecule. So we can, for example, if I have C2H4 and we can make it C3H6. So if I have C3H6O2, then that's a molecular formula. It doesn't really give you a lot of information about how the atoms are arranged. So no information is given. The next type of formula is your structural formula, and when you have a structural formula, that gives you, and there are many different types of structural formulas that provide you with a lot of information about how the atoms are arranged. Now, the first one is known as a fully displayed formula. Just one. So the first one, so let's take C3H6O2, a fully displayed formula. That's part A of a structural formula. That's the first version. So if they ask you to draw a fully displayed formula, all you have to do is you have to show everything. So every atom and bond has to be shown. And bond has to be shown. Most of the stuff you already know, so we just quickly recapping everything. So this is what a fully displayed formula would look like. So I'm drawing every single bond and atom. But then, just like structural formulas, you have, I mean, this is a fully displayed formula. You've got another type of formula, which is another version of what a structural formula is, and that's, you can write it in condensed form. So you can have a condensed structural formula. Now, in the condensed structural formula, all you have to do is you don't, I mean, for example, over here, the condensed version of this molecule over here would be like, if I were to write a condensed version of this, then it's going to be this one. It's going to look like this. It's going to be, you just sum up all the atoms So the first one, it's carbon with 3 hydrogens. The second is carbon with 2 hydrogens, and then you have a carbon with an oxygen and also with an OH. So that's your condensed structural formula. And when you're writing these condensed formulas, you got to be careful about branches. So condensed formula of branched. So if you have a branched molecule, things would be slightly different. For example, if I have this thing, I've got CH3, or let me just draw the whole formula. So just 3 more C. Now, how do you write this in condensed form? All you have to do is you've got to just travel left to right. And whatever comes in the way, you just keep writing that. So the first one is carbon with 3 H's. So that's the first one. Then you've got the second one, it's a carbon, which is directly bonded to an H. And whenever you have a branch, something that is coming out of the main chain, you put it in brackets. So this carbon over here has an H directly linked to it, and it's got a CH3 branch, which is going to be written in brackets. Then the third one is again carbon with that is directly bonded to an H, but it also has this branch that's coming out of it that's sticking next to it, and that's your CH2OH. And then you have the last one, which is CH3. So that last one is CH3 again. So remember how to write branches when you're writing the condensed formula. Another thing about condensed formula is that certain functional groups, most functional groups would be written exactly the way they're supposed to be. Like if you just start reading this from left to right, this is exactly that. It's CO followed by OH, CO and OH. The same goes for OH. But to differentiate between alcohols and aldehydes and ketones, what is done is, so to differentiate, so the difference between aldehydes and alcohols. So in this case, what needs to be done is, like if you have an aldehyde, if you remember what an aldehyde was, an aldehyde has a double bond O and H. And an alcohol is obviously an alcohol, it's got OH. Now, when you write a condensed version of this, this one can be written as CH3 and COOH, but instead it's always written as CHO. That is how an aldehyde would be written. This thing would not be written as OH. I mean, you could have written CO with an H, but instead it's written as CHO. Just to differentiate it from, I mean, this would be CH3, CH2, and OH. So an alcohol is written as OH, while an aldehyde is written as HO. Okay, so that's your condensed formula. You've got your fully displayed formula. Is this clear?
Yes, sir.
Yes, sir.
And then there's a third version of a structural formula, and that's your skeletal formula, which you've already studied. So this third thing is, just a second. No, Nadine, we'll come back to it as well. With the topics that we have missed, we'll do that again. We still have a lot of time till May, June. So you started with organic. That's more important. We'll do the other ones. There's just two or three left that you one or two left that you haven't done. So part C, the third type is skeletal formula. You've done skeletal formulas as well. Skeletal formulas is you don't show anything. You just don't show. The only thing that you show is carbon, and carbon bonds are shown only. And any functional groups that you have. So for example, if you have this molecule, so if you have this molecule, the only things that you're going to show is you're going to show zigzag lines. For example, you've got this carbon, you've got a second carbon, a third carbon, and a fourth carbon. So think of these four carbons as nodes, and so that's 1, 2, 3, and 4. So that's 1, 2, 3, and 4 carbon atoms. And on the last carbon atom, you've got a double bond O and OH. So you will show the functional groups. And on the second last carbon, there's a double bond O. So nothing else is shown. That's your skeletal formula. If I were to draw the skeletal formula of this molecule over here, so that's so this one over here is 1, 2, 3, 4 carbon atoms in a line. So I'll just draw those 4 carbon atoms in a zigzag manner so that's 1, 2, 3, and 4. These nodes are your carbon atoms. So that's 1, 2, 3, 4 carbon atoms. On the second carbon atom, there's another carbon atom. So on the second one, there's this other carbon atom that's coming out. And on the second last one, there is another carbon atom as well. So you can see over here, that's your second last one. There's another carbon atom, and that one has an OH as well next to it. So I'm going to write OH. So that's the skeletal formula of this molecule. So 4 carbon atoms in a line, that's 1, 2, 3, 4. Second one, there's a carbon atom, and on the third one, there's another carbon atom. So that's this one and this one. They've got 2 carbon atoms, and this carbon atom further has an OH group attached. So you draw so this is how you draw the skeletal formula. Hopefully everyone knows this already. Is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
So then we can move towards, so remember 3 types of formulas. You have to be careful, like even in the questions in A2, they're going to be very specific. You're either drawing the skeletal formula or the structural formula. They'll be very specific in the question. Like if they ask you to draw the structural formula only, you could draw any one of them. You can draw any one of them. But if they're very specific, then you have to be specific as well. Most of the time, you can't draw fully displayed formulas because it takes a lot of space. Most of the time, they're looking for these condensed formulas because they will just give you a single line to answer or to draw the whole structure. So you wouldn't be able to draw the fully displayed formulas. So most of the time, they expect you to draw the condensed version. But even if you draw the other one, that wouldn't be wrong. But if they're very specific, then you have to draw the specific version of the structural formula. Now let's move towards naming. You're already familiar with a lot of functional groups. There are no new functional groups except for benzene. The old ones are kind of the same. It's if you have the first one, I mean, the suffix is going to be, I mean, the first thing is when you're naming it, I mean, you should know the counting. It's going to be meth, eth, prop, but, and then it's going to be pent, hex, hept, and after that you'll have oct and non and dec. So you'll have oct, non, and dec. So you should know your counting. Molecules are named according to the number of carbon atoms that they have. And then you have a suffix. The suffix depends on the functional group. So suffix is the part on which the molecule is going, the name is going to end. So the first one is an alkane. Alkanes are obviously going to end with "ane," and I don't have to explain that. The next one is alkene. It's going to end with "ene." What does it have? It has at least one. So it has at least one double bond. One double bond. These ones are known as saturated molecules. And when you have at least one C bond C, you'll be referred to as an unsaturated molecule. The third one is alcohols. So it's going to end with all. The functional group for an alcohol is obviously OH. Then you have carboxylic acids. So the suffix in this case would be oic acid, like ethanoic acid. And the functional group is going to be C double bond O and OH. And you'll have aldehydes and ketones. These are known as carbonyl compounds. So the first one is an aldehyde. The suffix for an aldehyde is where you have, I mean, the suffix is al. And what's an aldehyde? An aldehyde is when you just have a acetyl bond O appearing right at the end of the chain. The second one is the second carbonyl compound is a ketone, where you have the suffix is "-one" and you've got C double bond O somewhere in the middle of the chain. So it's got carbon chains on both sides. So for now, that's about it. We'll just stick to this. Then we'll move towards A2. So that's the first basic thing. And molecule naming is going to be slightly complicated because the first thing is it's simple molecules. Like if you have simple straight chain molecules, that's easy. So simple straight chain molecules, for example, this one, it's 1, 2, 3, 4, And there is double bond O and H, and this has 2 hydrogens. This one has 2 hydrogens. This one will have 3 hydrogens. So the prefix or the starting name is going to be 4 carbon atoms as bute, and it's an aldehyde, so it's going to end with al. So that is what this molecule is. Similarly, if you have a molecule which, just a second, just hold on 1 second. Is this clear up till this point?
Yes, sir.
So just give me 1 minute. So a few more simple straight chain molecules. We'll have, this one, it's, what is this called? Like if I have, so what is the name of this molecule? Okay, anyone? Alicia, Nadine, Ibrar, Bazga?
Butane 2-on.
Okay, so this one is butane 2-on. Okay, so now things are slightly getting complicated. One thing is you would have to give the position of the functional groups. So you have to provide the position of the functional groups, and you're going to count from the side that gives the smaller number. Okay, but we'll come to position later. So position of the functional group has to be mentioned. Sometimes it's not going to be mentioned. For carboxylic acid, the position is always number 1 because it's always at the end of the chain. So you don't have to mention positions of a carboxylic acid functional group, or for an aldehyde. You don't have to mention that. But for alkenes, you would have to also mention the position of the functional group, and it's going to be written right before where the functional group suffix is. So for example, if you have this molecule, then this molecule is going to be 2 hydrogens. This one will have 1 hydrogen. This one will have 2. So this one would be bute 1-ene. So right before the suffix, you would have to write the functional group. The second thing is, now slightly more complicated molecules, still straight chain, but slightly more complicated. What if you have multiple functional groups, like more than one functional group? And you've got molecules that are saturated or unsaturated. Or unsaturated. So if you have more than one functional group. Now in this case, let's take this molecule over here. So the question is, it's got a double bond, it's got an aldehyde as well, group, and it's got an alcohol as well. And there is, let's add a chlorine as well, just to make things more complicated. And there are 2 hydrogens, that's it. Now, when you have a multiple functional group, remember there's a concept that there is importance of functional groups that you name the molecule according to their importance, and that's the precedence of functional groups. Now, the precedence is such that the carboxylic acid functional group has the highest precedence. That's the one that's so you're going to give the most importance to this group over here. Then you've got your aldehydes and ketones. Then you have your alcohols. And then you have your amines as well. So this is, let me just quickly check. I mean, you don't have to remember the whole nomenclature in detail because it's too complicated and doesn't work most of the time. Remember these nomenclatures. Where's the Wikipedia page? As anyways, they don't work for very complicated molecules. They usually work for molecules that have a certain, they are simple enough. So here's the order of precedence of functional groups. You've got carboxylic acids, including their derivatives, but we don't have to go into that much detail. Nitriles is one that we have missed. So let me add nitriles before aldehydes and ketones. Nitriles are the ones where you have C triple bond N. Again, nitrile is not a homologous C's that we study. So then you've got aldehydes and ketones. Let me just arrange the aldehyde before the ketone because the ketone actually has a lower precedence. And so that's about it. Alcohols and then amines, that's it. So that would be sufficient. Even nitriles is like, I mean, you don't need to know that as well. But anyways, that's your precedence. So the most important ones are the ones that are right at the top. So basically your carboxylic acid is the one that's really important, or anything related to a carboxylic acid. That includes lots of functional groups. But again, the details are not that important. So if you have a molecule, so what do you do with precedence? The precedence helps you naming. The molecule is going to be named or not the molecule. The suffix is decided by the highest precedence group or the main suffix. What do you call the molecule? So the suffix or the part where the molecule name ends with is decided by the highest precedence. So if you have a molecule that has an alcohol and an aldehyde and a carboxylic acid, you're going to call it a carboxylic acid because carboxylic acid, it has the highest importance. So the naming or the suffix is going to be decided by the highest precedence group. But what if a molecule is if a thing is not the highest precedence group? For example, alcohols, they become your hydroxy branch if they're not your main or highest precedence group. And the same goes for amines. NH2s, they turn into amino branches. You start treating them as branches. Ketones and aldehydes, they always remain as suffix. So here's what's going to happen. Like if I have this molecule over here, it's got 4 carbon atoms. So that means it is bute. So I'm going to call it bute. That's your prefix. So that is going to be that is going to be bute. And what do I call it? It's got an alcohol. It's got 3 functional groups. It's got an alcohol. It's got an aldehyde functional group, and it's got an alkene as well. And there's a chloro Cl as well. So which one is the highest precedence group in this molecule?
Aldehyde.
Okay, so it's an aldehyde. So I'm going to call it an aldehyde, and the name is going to end with Al. So I've figured out that it's going to start with but, it's going to end with Al. Now, every molecule is going to have An in the middle. It's either going to be An or En. So this decides whether the molecule is saturated or unsaturated. So in this case, this decides whether it's an alkane or carbon atoms are making single bonds or carbon atoms between them are making double bonds. So in this case, they're making double bonds. So I'm going to call it an En. So this is going to be referred to as but, En, and Al. The next thing is about counting which group comes at what position. And what do I do with the OH? So if the OH is not your, if you're not naming the molecule based on OH, this would become your branch. You would call it a hydroxy branch. Similarly, chlorine, the molecule is never named after chlorine. So it would always be treated as a branch. It will always have the lowest precedence. So you'll just call it chloro. So there would be 2 branches. This is going to be your main chain. So that's your main chain. All the other things would be referred to as branches. And the branches are always named alphabetically. So it's going to be chloro and then hydroxy. So these are your branches. You got your main chain, you got your branches. Now the next thing that needs to be added is what about the position and the numbering of the group? Which group is at what position? So remember, that's where the precedence comes in again. The precedence or the numbering or the position. So the smallest position has to be given to the, that's the first rule. There are multiple rules for this, but we'll stick to just one rule, the most important one, which is give the smallest position to the highest precedence, group. So which side should I count from? Should I count it from the left or the right?
Left.
Left.
So I'm going to count it from the left because I want to give the aldehyde the smallest number. So aldehyde would be at position number 1, then you have position 2, then you have position 3, and then you have the 4th carbon. So that means the hydroxy is at position 4. The chlorine is attached to the 3rd carbon atom, so it's 3-chloro. The double bond is at position number 2. So before the En, I'm going to add 2 over here. And the aldehyde is at position number 1. Since it's always going to be at position number 1 because aldehyde is usually the most important functional group. So you don't actually write 1. 1 is something that you just ignore. Like if it is 2, if there's nothing written, that by default automatically means that it's 1. So 1 is something that is usually ignored. So this is the name of the molecule. So again, this is still a simple molecule because it's not got any carbon branches. It was just a straight chain molecule with 4 carbon atoms. If you have multiple functional groups, the name of the molecule, this main suffix, is going to be decided by the highest precedence group, which was aldehyde in this case. And the other thing is, all the other groups, then they kind of become branches. So what if I have another molecule, and this time it's something like this. It's so you got a double bond OH, and you've got And let's say you have two OHs now. And this is your two H's, one H. And you've got a ketone over here as well. Just make it more complicated. First thing, what would you call this molecule? It's got 4 carbon atoms. So what would it start with?
But it would be but and oic acid.
TK. And the highest precedent functional group, that's a carboxylic acid. So everything, the counting, everything would be started from here, and then the molecule would be named after this. So it's going to be, I mean, the main suffix would be oic acid. And is it going to be AN or EN in the middle? Is it saturated or unsaturated?
AN.
Teak. So it's going to be AN. Because it's in, I mean, all the carbon atoms are making single bonds with each other, so it's going to be AN. And now we start bringing in all the other functional groups that are attached. So you've got OH. Now OH would become your hydroxy. It would be treated as a branch now. So that's hydroxy. This one is also. So you've got 2 hydroxy branches. So you're going to call them, either you can write them separately, or you can, as a branch, you can just call it dihydroxy. And you would have to give the position of each one of them. So the position, the counting would be done from, this is carbon number 1, 2, 3, and 4. So that means one of the hydroxy is at position 3, the other one is at position 4. So it's 3,4 dihydroxy. And what do I do with this last one, which is acetyl bond O? Now that's obviously a ketone. And since it is a ketone, and it's a ketone that's at position number 2, ketones would always remain a suffix. They would always be called, there would always be a suffix. So you're going to write, the molecule is going to have 2 suffix. It was oic acid, that was the main one, but there's going to be another one, which is your ketone suffix. So it's going to be butane and one, and then oic acid. But for a ketone, you would have to give the position. The position is 2. So before the ketone suffix, you're going to write 2 over here, and you can bring all of them together. So that's the name of this particular molecule. So again, I'll just quickly repeat that that carboxylic acid had the highest precedence. So the molecule was named after that. The other ones had lesser importance. So you had a ketone, you had alcohols. Alcohols would turn into hydroxy branches. So the branches would be written right in the beginning. And ketone, even though it's not the highest precedence, it still remains this suffix, but it becomes a secondary suffix. Like it's oic acid, but you're going to put in the one as well for ketone. And for ketones, you would have to give the position as well, because you have to tell them where the acetyl bond O is. So you'll put in 2 over here. Is this clear, this one?
Yes, sir.
Yes, sir.
So there's just a second. We'll there's just one thing that's left, and that is the branched. With branches. Like if the carbon chain is not straight chain, if it's got many branches, so how do you select the main chain? So remember, the molecule is going to be named with a main chain. And you'll write the branches in front of them in an alphabetical order. And before the branches, even in the main chain, if you have anything, you have to give the position. Like if you have a double bond, you have to tell where the double bond is. If you have only things that are appearing at position number 1, for them, you don't have to give the position. Anything that's appearing at position number 2 or 3, the position has to be mentioned. And so each of the branches would have positions. And everything that's included in the main chain is also going to have a position. So if there's an own, you're going to give its position. If there's an in, you give the position of that group as well. Then we'll continue from there. We'll just do the branched molecules now. Okay, that's the only thing left in naming. Let's continue tomorrow now. Okay, Claire, is there any?
Thank you.
Yes, sir.
Okay,
Yes, sir.
take care.
Okay, sir. Thank you.
Thank you, sir. Allah Hafiz.
Allah Hafiz.
Allah Hafiz.